So, this is episode 24 of our fluid mechanics tutorial. Today, we are going to continue our discussion about energy losses and to cover minor loss in pipe flows. So, what are minor losses? In straight pipes, we have major losses, but if the pipe is not straight, then there are some additional energy losses due to geometry. These are the three items that we are going to talk about. And again, V squared divided by 2 have the same dimension as energy per unit mass. So again, people use this to compare energy loss due to minor loss and design a loss coefficient for minor loss. And the total energy loss is given by the minor loss plus the major loss. But the word minor here does not imply that the minor loss is really less than the major loss. Sometimes, the minor loss can be larger than the major loss in short pipes with many curves and components. So, let's discuss the three items. First, for entrance and exit condition, for entrance, the loss coefficients are rather empirical, but for the exit, you shall learn about that. For any geometry here, the loss coefficient for an exit to a reservoir is always 1. So labeled here are the 2 points, and we call that and this elevation difference is fully compensated by the hydrostatic pressure here. These terms cancels out. Considering this term, we think of the continuity equation. But for a reservoir, the area is really large, so the velocity S2 is 0, and this is 0. So the energy loss is just, and we guess the loss coefficient is 1. So let's talk about sudden contraction and expansion. The sudden expansion is our only case that we can derive theoretical result. We can do so by control volume analysis. I think you can try it yourself. But for sudden contraction, we cannot do such thing, since the supporting walls provide an anchoring force to this control volume, and no one knows how much force the wall has provided to the flow. And the book also have a list for pipe components. In the textbook, there are some problems that require you to look at the table, but often in the exam, the loss coefficients are provided. So, let's do our first example. The question requires that the energy loss for major is 10% of the energy loss for minor. But we look at our flow. Here we have an entrance going like this. The entrance condition looks like this in the figure, and this gives the loss coefficient equals 0.8. And at the exit, it is going out to a reservoir, so it is always 1. So the total loss coefficient is 1.8. We recall that the major loss is in fact, and the minor loss is, and this cancels out. F here is 0.02. L here is ND, so this cancels out. And we have got N equals 9. So let's move on to our next example. Let's let 3 points here, 1, 2, and 3. And we assume that the flow is turbulent, so alpha equals 1. Then we apply energy equation between 2 and 3. And both 2 and 3 are exposed to the atmosphere, so this goes away, and point 3 has 0 velocity. And also, all the losses except the loss here is negligible, so this term also goes out. And what we are left with is, and this distance is h, and this is our first equation. Then, we apply the continuity equation between 1 and 2. And it is 5 times. And if we plug this result into our first equation, so this is our second equation. And then we can do an energy equation between 1 and 2. So point 2 is now exposed to the atmosphere. And then we can substitute in the values. And since 3/1 squared is GH divided by 25, we can further substitute this in. But this energy loss here is the loss coefficient times, and again, this term here is, so that we can combine these two equations and get H equals 10 and KL equals 50. And the first condition is that H equals 10 and KL equals 50. So we substitute that in. And the second condition is that H equals 20. So we again substitute that in. But then the right hand side of these equations are equal. So what we get is and this cancels out, becomes 2, so that KL equals, and that is 13. Before we look at the next example, let's recall how to calculate for major losses. So I copy the slides from the last tutorial and add a statement here. The next example is to find the total energy loss. So let's recall how to find the major loss. First, we have to determine whether the flow is laminar or turbulent, then use the corresponding relations. Finally, we can sum the major loss and minor losses. So let's really work on an example. Cavitation means that the lowest pressure is more than the vapor pressure. The lowest pressure shall be in this point. So let's let this as 1 and this equals 2. So let's go ahead and write down the energy equation first. Now, P1 is the atmospheric pressure, and this point shall at least have the vapor pressure for cavitation not to occur. Now we already know the pressure at point 1 and point 2, and difference in their elevation. But what are these two terms? One is this point, so it shall have zero velocity, since it is far away from the syringe. But do we know the velocity at point 2? To think of the velocity at this point, we apply continuity equation between the velocity here and the velocity here. So we take this as V. So V2 is just 1 divided by 1600 of V. And that is also approximately equals 0, since the velocity as the needle cannot be too fast. So these two terms both go away, and we cannot plug in the values. And point 2 is 0.12 meter above point 1. And we assume that the flow is laminar here, so the major loss is and for the minor losses, here we have a sharp entry, and the exit is always 1. So we have loss coefficient equals 0.5, which is due to the sharp corner, and 1 due to the exit. V squared divided by 2. And by quadratic formula, we now have a velocity. We can find the Reynolds number. So let's check if the flow is really laminar. Which is well below the limit. So finally, we can calculate for the flow rate. And we are done with this example. Today we covered minor loss in pipe flows, and such kind of energy loss is due to geometry. There are 3 types of minor losses, And we also went through a big example that involved the total energy loss. The total energy loss is equal to the minor loss plus the major loss. And we shall see more examples in the next tutorial. This is the end of this tutorial and thanks for watching. Feel free to ask us any questions and give us any feedback in the comments below.